Good morning to everyone. Today we are going to learn several topics in thermodynamics, and I have mentioned the class learning objectives like this way: reversible and irreversible process, difference between reversible and irreversible process. So first we will define two different terms or different processes which are reversible and irreversible, and then we will learn the difference between the reversible and irreversible process. Then we will learn about the sign convention of heat. That means how we consider if the heat is positive or negative. So we will learn that how we are considering that if the heat is absorbed, then it should be positive or it should be negative. So we will learn the convention of sign for heat. Then also we will learn together the sign convention of work. After that we will try to learn about the pressure volume work, and finally, if I have enough time, then isothermal reversible expansion of an ideal gas. So these are the class learning objectives of today's class. So let's start from the reversible and irreversible process. So in thermochemistry or in equilibrium, you have learnt about the reversible and irreversible reaction in chemistry. That means not in thermodynamics like this way, but I think you are familiar with the reversible reaction. That is very familiar with you. That means if any reaction which can proceed at the same time forward and backward direction, that is known as reversible reaction. But now we will consider in terms of thermodynamics. That means if there is any system what you can change in very slow way or very slowly, very small step, in very small step, let us consider this is a system. So if you put, this is intermediate position, this line, this is a cylinder full of gas, and these are the position of pistons. So this is a piston, this is a piston, this is a piston, but this is our initial position. So I'm getting noise, so please mute yourself if you do not have anything to say. So consider a cylinder with frictionless piston. That is not really possible. That is an imaginary term. Frictionless. In the universe there is nothing that can be completely frictionless. When we walk on the road or we drive car or bicycle or whatever in the road, in that time we need the friction, but we may reduce the friction by polishing or using some other greasy chemicals, but actually in reality there is nothing like as frictionless. The friction can be very little. However, there is nothing in the universe which can be considered 100% frictionless. However, we are considering like as imaginary. So this is a cylinder with frictionless piston, imaginary term. This is also frictionless piston. So now if the volume of the gas, this is a gas and this is the intermediate position, that means initial position. Now if you put the piston or if you put little bit pressure, very small, very little bit, to reduce the volume of the gas, here if it was here in the initial stage, now if you increase the pressure over the piston, in that case the volume of the gas will decrease a little bit. So that should be infinitesimal change, that means negligible or very close to zero. So if you change that small amount of the volume, or if you increase the pressure by that infinitesimal change, in that case the volume of the gas will decrease a little bit. In that case the mm, condition, the density or other properties of the inside the gas will be same for everywhere. That process, that will take very long time to change, but you should not change it drastically or very short time. So a thermodynamic reverse process is one that takes place infinitesimally slowly. That means it will take very long time or in very short change. So infinitesimally slowly, and its direction at any point can be reversed. So if you change or if you increase the pressure over the piston and if you remove the pressure of the piston, immediately it will go back to the initial position. So it can be reversed by an infinitesimal change in the state of the system. So if there is any system, that is when you change the infinitesimal change with very long time or very slowly, and it can be easily reversed by changing the situation or condition, then that system can be considered as reversible system. So we can have another idea just opposite to this. So we have mentioned about the reversible process, like us comparing the reaction, but reversible reaction and reversible system is not exactly similar. Reversible reaction, that means if any reaction can move forward and backward at the same time, that is considered as reversible reaction. But reversible process is, or reversible system, if you have a system by changing a very small anything, by changing very small amount with very long time or very slowly, and if it is possible to go back to the initial stage, or it can be reversed with the changing the applied stress or situation, so we can consider that system as reversible. Then how we can consider the irreversible? Previously I have mentioned one term, that if you change the volume of the system just very small, very close to zero, that means if you consider this line comes to just little bit below, in that case the total amount of gas inside the cylinder will be same, and the pressure inside the gas will rise very little, because volume has been changed very little. So the pressure inside the volume or inside the container will increase a little bit, but which is very negligible. So everywhere the pressure or the component or the ratio of the whatever the gas molecules we have, that will remain everywhere, even just at the bottom. Where is my cursor? At the bottom or at the top, wherever, everywhere, because you are taking very long time to change the system. In that case it has a long time to distribute the molecule everywhere, so that it can get the density or number of molecules or the components everywhere same. So if you reverse the system, exactly you will get the same thing. But in case of other system, what we are considering now, if you have a system and you are changing the condition, you can increase the pressure of the gas or you can decrease the volume of the system in rapid process, very short time, within fraction of second or within couple of seconds. Just if you change the pressure or you increase the pressure by this piston, in that case the volume, this is initial position, that means initial position was here, let us consider. Now you are increasing the pressure from the piston, so that the volume decreased quite a lot within a very short time. So what will happen? the number of molecules just beside the piston will have more density. So the number of molecules of the gas will have more components in this region, but at the bottom the number of molecules or components will be very less. So that system cannot be reversed if you remove the pressure immediately. In that case you cannot go back to the initial position, because the density or the properties of the system has been changed due to this process is irreversible, so it cannot be go back to the initial position. So we are considering this is a irreversible process. So and one other thing, that for the reversible process, this is a very long time process, and the density, concentration, number of components, whatever, everything is same for every time, in every step of the time, or how much change you are doing, that is everywhere this is same. But in case of irreversible process, the system is equilibrium only in the at the end or at the beginning, because initially the system will be in equilibrium, because if you put a system or a cylinder, a full of cylinder with gas, in that case all the molecules will distribute everywhere. But if you compress the gas, then the concentration or the pressure will increase, but after certain time all the molecules will distribute everywhere, but not in between the time when you are changing from initial to final position. In that case, the system which is considered as irreversible, the system is not equilibrium during the change, but it is in equilibrium at the beginning or at initial and final stage. So let's see some of other differences what we are learned about the reversible and irreversible process. Difference between reversible and irreversible process. So first, reversible process, already I have mentioned, it takes place in infinite number of infinitesimally small steps. So the reversible process, you need to change the system with very long time or very slowly with very small change or very short change. But irreversible process, it takes place in finite time. So here I think a little bit problem, in there is a space not infinite, so it should be in finite time, fixed time. So it is imaginary as it assumes the presence of frictionless and weightless piston. So that is also I have mentioned that in the universe there is nothing related or nothing 100% accurate frictionless. So every time we have some friction for in between the piston and the body of the cylinder. So it is an imaginary situation. It is a real and can be performed actually. Just when you consider like as a cylinder or some any other piston, whatever syringe, you can consider a syringe what we use for taking medicine or any other purpose. So you can use a syringe and immediately you can push very fast. So if you hold one finger at the bottom end of the syringe, in that case you can feel, if you put the pressure over the piston, in that case you can feel that the pressure, inside pressure has been increased quite a lot. If you close the close the mouth of the or end of the syringe with your one of the fingers, then you can feel that the inside pressure has been increased. Again, if you want to increase the volume of the cylinder or syringe, you can feel that your finger is attacking to the, or it is tightening to the syringe, therefore you can feel that the inside pressure has been reduced quite a lot. So you can perform the irreversible process in real time, but the reversible process, this is an imaginary situation, so it cannot be performed in real time. Then it is in equilibrium state at all stages of the operation. That means reversible process, we need to perform the process with very long time and by changing very small steps. So every time or every situation at the initial, final or in middle, everywhere it is in equilibrium. But in case of reversible process, it is only equilibrium at the beginning or initial and final stage. Then all changes are reversed when the process is carried out in reversible direction. So if you change the pressure, if you increase the pressure to happen the reversible process, then if you want to go back, that means in reverse direction, in that case the pressure will be reduced. So that is just all changes. If you increase the volume or decrease the volume, in that case just opposite will happen during the reverse process of the reversible system. But for irreversible process, some of the property will not come back exactly in the situation, or it will not reverse exact way. Then number 5, it is extremely slow, the reversible process. Already mentioned that the process you need to change very small steps, so with very long time. So this is very slow process, but for a irreversible process, it proceeds at measurable speed. Measurable speed, that means it takes quite long time, so that you can use stopwatch or your watch, any watch or anything, just you can measure the time. That means that is in measurable speed. Work done by a reversible process is greater than the corresponding irreversible process. Okay, that means when any irreversible process, later we will learn about how we can calculate the work done during a reversible and irreversible process. That time we will see that the reversible process and irreversible process has the work done in different formula, so that some of them will perform some work due to increase the internal energy. So that will be little bit different compared to irreversible or reversible. In between these two we will have some difference. Now what is the sign convention of heat? This is a system. If you have a closed system or open system or any other types of system, as already I have mentioned in the first lecture, maybe, yes. So in the first class I have mentioned about the open system, closed system, like this. So if you have a system and if some heat or energy, this is our system, and outside is considered as surroundings, and this line, you can consider this black line as our boundary. So if heat is absorbed, that means if heat comes into or inside the system, that means the total energy of the system increases. In that case you will consider the sign as positive. So for any system, if I mention, maybe later I will show you some mathematical problems. In that case we may mention it is sign, we will not mention the sign, maybe sometime we will mention that our system changes from the volume from that to that, or pressure increases, or some in heat increasing, like this way. So in that case you need to understand if the sign is positive or negative. So you need to calculate some mathematical problems by understanding if the sign is positive for the heat or it is negative. So just I am giving you the example, mentioning or defining, if the heat is absorbed or come inside the system, or the total energy of the system increases, in that case you will consider the sign of the heat is positive, So other way, if the energy escape from the system or the total energy of the system decreases or some energy go out of the system, that is known as the sign should be negative. So that is very simple. So just remember, if the energy of the system increases, then the heat will be positive, and for other case the heat would be negative. Okay. So for work, actually in physics we know work equal force into displacement, is it? W equal Fx. So if you perform a work, that should be some sign, because work is directly related with the force. So force is a vector quantity, so it should have some sign. So always we need to consider if it is positive or negative. So the symbol of work is W. So if work is done on a system by the surroundings and the energy of the system is thus increased, it is taken to be positive. Just what I have mentioned here, if any work is done on the system, this is our system. So if some work is done on the system, the total energy of the system increases. So we will consider some work is done on the system. So by applying some energy or some force or whatever, if you apply some force or energy or whatever to perform some work in the system or on the system, then we will consider the work is positive. And if some work is done by the system, just remember the difference. Work on the system would be positive and work done by the system. That means if the system itself, do some work over the surrounding, in that case the sign of the work will be negative. And just remember one thing, that will be enough to remember the sign of the heat and work. If you can remember the sign of the heat, that will give you the exactly sign for the work, because the work is a term considered as heat. So we can consider if the heat of the system increased or work is done on the system, or total internal energy or total energy of the system increases, therefore we can consider the work is positive or also heat is positive. So I am not going to discuss other one very often, because if you can remember one, then always you can remember the opposite one. Okay, just here remember, heat flows into the system. As already mentioned in the previous slide, heat flows into the system, Q is positive. Heat flows out of the system, Q is negative. And work is done on the system, W is positive, and work is done by the system, W is negative. So remember these two lines or two statements, that will be enough to understand what would be the sign for the work or heat. Okay, now we will learn about the pressure volume work. Pressure volume work, that means work, here is the work equal F force into distance. Just force is a vector quantity already mentioned, and you are familiar with the, and also you have learned from SSC and ICC level. So what is work? Work is the multiplication of force and the distance, multiplication of force and distance. That means if you can displace some substance or something by applying certain force, in that case you have performed some work, and the amount of work would be the multiplication of the force and the distance or displacement. So if you have some, if you do not have any displacement, any movement, That means no movement of the substance, that means no displacement. Even if you apply very huge amount of force, still there is no work, because this is the work term, or work is the multiplication of two different terms. If this term or this term, any of the two terms is 0, in that case the whole term will become 0. Therefore you can consider that you need to have some minimum value to have the work. So we can use the symbol for defining the work, W equal F into L. This is a cylinder, as we have mentioned in the previous system, reversible and irreversible process. So exactly same thing. Let us consider a cylinder with a frictionless piston. Let us consider a cylinder with a frictionless piston. This is the piston, and some inside there is some gas. So the total pressure of the gas is P at the initial stage. Now if you apply some force or pressure, if you apply some force over the piston, in that case the force F will apply some pressure on the piston, and the exactly same pressure will apply this gas. Inside there is some gas, because this gas will exert some pressure over the piston to displace from the, so when we apply some force here, so if you apply very high force or very large force, then the pressure of the cylinder, sorry, the piston will exert this pressure over the piston, and the volume of the gas will decrease. Now if you change very small amount of the pressure, or if you apply very small amount of force, in that case the volume change will be very small. Now let us consider how much work we are doing here. So if you have, this is the initial position of the piston, and the volume of the gas, certain volume. Now you have changed, maybe we can consider other way. If we consider this is our initial position, or this is initial position, and we are moving other way, so it will exert some pressure. Let's see, since pressure is force per unit area, so you are familiar with the definition of force. What is the force? Force is the pressure multiplied pressure per unit area. So F equal P exert, that means pressure applied to the piston multiplied by the area. That means around how long area the pressure is applied, that is known as the force. Okay, so where A is the cross section of the piston, this is a cylindrical cylinder, so the piston should be also a cylindrical shape. So if you have a cylinder and a piston, so inside volume of the, sorry, not inside volume, that the surface area or the cross section, that means if you consider, okay, last class I have shown you this one. So this is a one cylindrical shape. So this part is the cross section. If you just slice all many pieces, all of them will have some cross section, and this is the cross section. So if you consider this is the cylinder, and what I am showing here, this is the cylinder. Now if you put some piston over it, in that case you can have the how much work will be performed, the area of the cross section, this multiplied by the volume, or sorry, how much displacement happened. So here you can see W equal P exert multiplied by A into L. So from already you have found that F equal P exert, that means the pressure into A, where A is the cross section area of the piston. From equation 1 and 2, this is our equation 1 and this is 2. So if we put from 1 already we found F equal P exert into A, so just we can put here. So W equal P exert into del A into L. Now this is the cross section and sum of the length. If you consider this length, then we can find out the volume of the cylinder. Just what is the formula for the volume of the cylinder? Just pi r square L. This is the formula. So the cross section is the pi r square and L is the distance or length. Therefore easily we can find out the volume pi r square L, or as already we have mentioned, this is the area. So just to get the volume we need to multiply the distance or displacement or the length. So W equal P exert into delta V. So area into volume, so length, that means height. So that is the volume. So just we put the symbol P exert into delta V. So this is A into L, that means delta V, where delta V is the increase in volume of the gas. So if you increase the, that means if you move the piston from here to here, so that the gas worked. So this gas work, that means system worked over the surroundings, where delta V is the increase in volume of the gas, since the system is doing work on the surroundings. As already I have mentioned that in the sign convention of work, if the system is doing work over the surroundings, that means the work is done by the system. In that case the sign of the work will be negative, and if the work is done on the system, then the sign of the work will be positive. So if we increase the volume of the gas, in that case we are getting, so the pressure, since the system is doing work on the surroundings, it bears negative sign, thus W equal minus P exert A and delta V. Yes, I have mentioned in previous slide, sorry, sign convention of work, what I have mentioned, that for a positive, here I have mentioned the sign convention of heat. This is our system. Now if you increase the heat, that means some energy is coming inside, that means the total energy of the system is increasing. So the sign convention, or we have to put positive sign for the heat. And similarly we have mentioned that now how you will get some energy inside, you need to perform some work on the system, so that you need to apply some force or pressure, so the internal energy of the system, or you need to apply some heat using your burner or whatever, any other way, or heater or whatever. So if you perform some process or work on the system, in that case the sign of the work will be positive and total internal energy of the system will increase. Therefore we will consider the heat will be positive and the work will be positive. Now if the system itself performs some work, that means if the volume of the system increase or decrease by itself, or that means the system is working over the surroundings, in that case the sign will be negative. So here what we have shown here, this is our initial position. Now if you consider the gas increasing the volume, so this is the system. So there movement of piston, here you have seen the symbol, the movement of the piston from this direction to this direction. So this is initial position, this is final position. So the volume of the gas increasing, therefore the pressure is decreasing, and this is our displacement. So the gas itself is increasing because the piston is frictionless. So due to having the pressure inside or some molecule inside, so the pressure or inside the molecule that will try to move the piston some away, so that the gas is performing work on the to the surroundings. Therefore the work done here is negative, so we are putting negative sign in the work here. Now if we consider the piston is putting pressure over here, so the volume of the gas decreasing and the work is performed by the on the system. So that time we will consider, that means the movement of the piston will be opposite way, that will from top to bottom it will come back way. So in that case our work will be performed on the system, so we will consider the work is positive. Okay. Okay, now we have some mathematical problem. This is very simple. Thank you. Solve problem. You don't need to write down SMS. You can ask me directly. There is no problem. Just you are mentioning in the chat room, that is okay. But you don't need to. Just it would be okay if you ask question. That is fine. Solve problem. What is the calculate the pressure volume work done when a system containing a gas expands. Here what we have shown here, this is our initial condition for the mathematical problem. This is our initial condition and this is our final condition. That means the calculate the pressure volume work done when a system containing a gas expands from 1 liter to 2 liters. That means the volume expands. Initially the piston was in the bottom and finally the volume expands. Therefore against a constant external pressure of 10 atmosphere. So this is our external pressure, what we are saying here, the external pressure. So for the mathematical problem we are considering that the volume of the gas increasing or expanding from 1 liter to 2 liter due to over the 10 atmosphere pressure. So at constant against a constant external pressure of 10 atmosphere, express the answer in calories and joules. So you need to calculate the pressure volume work. So from here this is our formula, but sign always don't need to be negative, because we have mentioned that if the work is positive then we will put positive sign, that means no need to put sign. And if it is negative, that means if the work is performed by the system then it is positive, and on the system that will be positive, and by the system that will be negative. So what is going on here? If the volume increases, therefore who will say if this is the work is performed by the system or over the system? In the mathematical problem I have mentioned that volume is expanding due to from 1 liter to 2 liter. Someone, if the work will be positive or negative?
Negative.
Okay, yes. So the work is done by the system. Yes. So here we can say that our volume is increasing, therefore the work is done by the system, therefore the sign of the work will be negative. So our formula is just W equal P multiplied by V2 minus V1, delta V. It was delta V, that means here in our equation it was delta V. So what is delta V? The change in volume. So change in volume is delta V. So V2 minus V1. So our V2 is 2 liter and V1 is 1 liter. So the pressure 10 atmosphere, constant pressure 10 atmosphere and sign negative. So we are getting 10 liter atmosphere. Now if you want to convert liter atmosphere to joule, just use the multiplying factor 101.325, just that will give you the in joule. And if you want to find out in calories, just you know the value 4.184 joule equal 1 calorie, just divide by the number, so that will give you. Oh, what happened? There is two terms. Why? This is our 101. Okay, divide by, yes, I thought something other mistake. Anyway, so this is the very simplest mathematical problem. Maybe you can have in the exam, or you may not have, because this is the simplest one what I think. So now we'll study about the isothermal reversible expansion work. I don't know if we can have enough time. Okay, let's start. If I cannot complete, then I will just end in somewhere. Consider an ideal gas. Everything same what we have considered, just now we are considering an ideal gas. Ideal gas means you are familiar with the ideal gas equation, PV equal nRT, like this.
Penalty.
Yeah, so that types of formula can be applied for these types of gas or these types of system. So isothermal reversible expansion work of an ideal gas. So let's us calculate how much work is performed when we are changing the volume or pressure of a system containing the gas of ideal or ideal gas. Now consider an ideal gas confined in a cylinder with a frictionless piston. Again, nothing frictionless. Sorry. Suppose it expands in a reversible manner from V1 to V2. So this is our initial position. So it expands from initial position. So initial position this is, and single intermediate step. So it is expanding. This is initial position, this is final position. So this is our smallest step. Actually we are showing this one is very large, because to visualize, to see, we need to have certain value, otherwise we cannot understand how much we have changed. In actual manner, for reversible system, what we have mentioned, that the change or every step, size of the step should be close to 0 or negligible. Therefore, suppose it expands in a reversible manner from volume V1 to V2 at a constant temperature. That means we don't want to change the temperature of the system, either not even in case of system and surrounding. If it need to be reversible, then you need to think about the temperature of the system and surrounding need to be equal. So if a system need to be reversible, in that case the surrounding temperature and system temperature need to be equal. Otherwise, due to difference in the temperature, the energy can be flow from inside to outside easily. So we are considering an ideal gas and confined with a frictionless piston, and the volume of the gas is expanding from V1 to V2 by very infinitesimally change or volume delta P or dP. The pressure of the gas is successively reduced as the volume of the gas. Here this is my initial volume and this is our total volume. So as the volume of the gas is increased, so what will happen? The pressure will be decreased, because the total number of molecules or components inside the cylinder when it was in a smaller volume and when it is bigger volume, always same. Therefore the pressure will be decreased quite a lot. The pressure of the gas is successively reduced from P1 to P2. So at this position or initial position, the pressure was high, and at final position the pressure is now quite low, and that means P1 greater than P2. Okay, the reversible expansion of the gas takes place in a finite number of infinitesimally small intermediate steps. So, reversible expansion. Reversible expansion of the gas takes place in a finite number of infinitesimally small intermediate steps. Just very small. So, we need to think about 100 or millions of steps, intermediate or very small step. To start with the external pressure Pext, it runs equal to the internal pressure of the gas P gas, and the piston remains stationary if Pext is decreased by the infinitesimal amount of dP. The gas is expands reversibly and the piston moves through the distance dl. So, sorry, this is our initial position. Now if the gas inside pressure of the gas is P gas, let us consider, or initial value was P1. So as the gas exerts some pressure on the piston, so the piston will try to move very slowly in a step by step or in very infinitesimal chains. So the pressure of this, and if we want to keep the piston steady, in that case we need to apply some pressure exactly equal to the pressure of this gas through the outside. Otherwise the gas will always try to go back because the piston is frictionless. Okay, now if it moved one step, that means dl, if we consider it is moving very little distance dl, in that case the pressure of the system has been decreased a little. So you need to reduce the pressure of that externally pressure whatever you are applying, so that the system, or sorry, the piston can be steady or on that position. Okay, if Pext is decreased by an infinitesimal amount of dP, the gas expands reversibly and the piston moves through a distance dl. Since dP is so small, for all practical purpose Pext equal P gas equal P. So here the initial pressure was P1 or P gas. Now if you change the volume very little bit, in that case the overall pressure of the system will be almost same to the initial pressure, just by changing very fraction of the volume. So the overall volume remain closely same but increased a little bit. However, the total pressure of the system will decrease a little bit. However, that can be considered equal to the initial condition or initial pressure. Okay, so for all practical purpose the Pext equal P gas equal P. So the work done by the gas in one infinitesimal step dW can be expressed as in the previous slides. I have shown you that the work done for a system in cylindrical system, what you have considered, that the work done on a system is pressure into volume. So pressure, this is pressure into this is our volume, that means this is the cross sectional area and this is the distance or displacement, and so overall P into delta V. Okay, then where dV is the increase in the volume, so the total amount of work. Now if we consider, if we want to perform or if we want to expand the gas from this position, this is V1 to V2, in that case we may need to consider millions of steps of very small steps. So in every step we are performing the work dW. Now if we want to move the position from here to here, or if we want to increase the volume from V1 to V2, in that case we need to do some integration over the V1 to V2. So work done here, so the total amount of work done by the isothermal reversible expansion of the ideal gas from V1 to V2 is, therefore we are using some integration limit. this is our function and this is our limit over the function, so that we are considering the what is the always if you need to find out the total work done, then you need to do the integration from where to where we are doing the change. So W equal minus V1 to V2, because we are giving the negative sign because the gas is expanding, so the work is done by the system, therefore the sign would be negative. So we are giving negative sign, so the limit is V1 to V2 and P into dV, that is the function. Now from the ideal gas equation, we are familiar with the ideal gas equation, PV equal nRT. Now we can write down P equal nRT. So easily P equal nRT by V. P equal nRT by V. Now just replace the P with nRT by V. So by the ideal gas equation we are getting this, and now P equal nRT by V, we can put this nRT by V here and then integrate. W equal V1 V2, this is our limit, and then nRT by V in place of P and dV is here. So this nRT, these are constant terms, so we don't need to do anything for the integration. So W equal, now what we have the variable part only dV by V. So I think you are familiar with the integration. So if you do not have, just learn here. So if you have the integration of dV by V in that case, or dx by x, just simply you are familiar with this term dx by x, in that case you can consider the integration would be, so what would be the, yes,
Ln.
yes, ln. Here you can see the ln, and so we are getting V2 minus V1 and just ln V2 by V1. So we are giving the ln V2 by V1. So that is our work done for the isothermal reversible expansion of gas, of ideal gas. Now we can express in another form. We have used here the volume, but we can express in terms of pressure also. So from the same formula P1 V1, we know from the Boyle's law, is it P1 V1 equal P2 V2. So we can write down, so V2 by V1 equal P1 by P2 from this equation. So we have V2 by V1, so V2 by V1 this is, so we can write down P1 by P2. So now we can write down W equal minus nRT into ln P1 by P2. Here you can see minus nRT ln P1 by P2, and so now ln equal 2.303 into log. Just exactly the same thing what I am writing here. So this is the work done by on the system when isothermal reversible expansion work of an ideal gas is performed. So if you have any question or comments on this lecture, then you are welcome. Do you have any question?